Hi, welcome back to the bunker. Today we're going to take a look at acid deposition, which really is the same thing as acid rain. So here we go. Alright, so what exactly is this? What we know is most coal-fired power plants and other industries use really tall smokestacks to get rid of their pollutants. To try, and that's been a strategy to try to get rid of air pollution, is to just shoot it high up in the sky and hopefully nobody will notice. All right, the types of things that normally come out are like nitrogen oxides and sulfur oxides, and also little particles that are going to go out there, hide in the atmosphere, and then the wind disperses them out there. It does help the area right there, but as we've learned with the atmosphere so far, the atmosphere is global, and winds will blow not just in cities, but also in states and larger regions as well. So where we are in Detroit, yeah, we put this stuff high up in the sky, but it still blows its way over into Canada and into Windsor and those areas to the east of us. Once they get in the air, these things that are put out by smokestacks are going to turn into secondary air pollutants. Remember, primary air pollutants were the originally emitted pollutant, like the nitrogen oxides or the sulfur dioxide or the particulates, those types of things. Those secondary air pollutants, that was where our primary pollutant mixes with something and becomes something else. All right, what we're going to focus on today is these nitrogen oxides and sulfur dioxide mixing with like rain and forming an acid rain. All right, so what will eventually happen is they can come down as rain, or like the particles that are in the air can be acidic sometimes, and they will settle on things. Kind of think of like a really light acidic snow falling type of thing. But it's not really snow, it's like dust. So it's acidic dust that is falling down. Now, an important thing with this to note, I'm going to bring out my highlighter here, if I can find it. There it is that the normal pH of rain is 5.6. So when we talk about acid rain, or this here it says wet deposition, it says rain, snow, fog, cloud vapors that have a pH less than normal. All right, rainfall is normally acidic. There is carbon dioxide in the atmosphere. When carbon dioxide mixes with water, it forms a very weak acid called carbonic acid, which gives rainfall a normal pH of 5.6, or neutral is 7. So with acid rain, or as it says there, the wet deposition, it's really any sort of precipitation that has a pH of less than 5.6. Right, that is an important distinction. Something with a pH of 6 is not going to be technically acid rain. Now, the important thing with this is most acid rain that we get worldwide happens because of human activities. All right, when we're adding excessive amounts of the nitrogen oxides and the sulfur dioxide to the atmosphere. And the main thing, and really the number one main reason for acid rain when it comes to human activities, is burning fossil fuels. Burning coal, burning oil, burning natural gas. All right, especially coal. Coal has a lot of sulfur inside of it. When that coal gets burned, that sulfur gets turned into sulfur dioxide, which is a main source of acid rain. There are other sources of acid rain. There are natural sources of acid rain, especially volcanic eruptions, for sure. But probably number one overall would be the anthropogenic sources of burning fossil fuels.
What is acid rain? Acid rain is any form of precipitation with high levels of nitric and sulfuric acids. It can occur in the form of snow, fog, and even dry materials that settle to Earth. Most acid rain is caused by human activities. When people burn fossil fuels, sulfur dioxide and nitrogen oxides are released into the atmosphere. These gases react with water, oxygen, and other substances to form sulfuric and nitric acid. winds may spread these acidic solutions over hundreds of miles. After it falls to Earth, acid rain enters water systems as runoff and sinks into the ground. This can make water toxic to crayfish, clams, fish, and other aquatic animals. The rest of the food chain, including non-aquatic species such as birds, is often affected as well. Acid rain also harms forests by damaging trees' leaves, robbing the soil of essential nutrients, and making it hard for trees to take up water. By designing cleaner power plants and using fewer fossil fuels, we can reduce the number of pollutants that create acid rain.
All right, so this map gives you an idea of where more people are being affected by acid rain. And it's giving you the darker colors areas are people per square mile in areas. So when we talk about acid rain, those darker areas are areas where you're going to see higher concentrations of acid rain. And if you look on there, that is mostly where most people are concentrated. So this is where we're going to be burning the most fossil fuels. It's going to be where we probably have the heaviest concentration of industry, especially over here on the East Coast. We have a pretty heavy concentration of industry, and that's generally where pH is going to be lower in our rainfall. And when you compare that, here's the idea. All of the red dots on there says there are major coal-burning power and industrial plants. Is where we find, this is where a lot of our electricity is. And we have these very low pHs. For that, every dot on here is a pH, so 4.4, 4.5. Over here in the Detroit area, we're looking at 4.7 in those types of areas. All right, when you get over here to the west, right, much higher pHs. A lot of them are above normal, or a lot closer to normal, but there are still areas where it is still below what the normal pH would be. So when you think about why that is, you need to think about where are most of our fossil fuel burning industries and most of our fossil fuel use is concentrated. Well, when you think about it, we have the majority of coal over here in the eastern part of the U.S. in this area. This is where most people live in the U.S., so there's going to be a lot of car traffic in that sort of area. And this is where most of our industry is. And for the most part, and when you look at major coal-burning power plants, this is how we're getting our electricity in this part of the country is through coal. When you get to the West Coast, they're using more hydroelectric and more alternative things besides coal. They're finding other ways to get electricity besides using coal power plants. And that shows that there's much lower rates of acid rainfall in those areas. So when you then put that globally, if you compare where you see the most industry, it's where you have the most problems with acid rain. Right? In the more developed countries of the U.S., Europe, Russia, these areas over here on the east, this eastern coast of China, they have huge issues there in China, as we saw in our air pollution notes, where we talked about the Asian brown cloud and all the pollution issues that they have over there. So why is acid rain a problem? Well, when it comes to humans, lower pH rainfalls actually makes, if you have respiratory problems, it makes those problems worse. Right? If you have asthma, right, that acid in the rain actually kind of almost think of it as like burning the lungs, making it harder to breathe. A lot of our statues and buildings, like if you've been to Washington, D.C., everything there is made of marble, and marble gets damaged in acid rain. All right, this picture over here is a statue in 1908 and a statue now. All right, where the features on that statue have just been eroded away by that acid rainfall. All right, they've found issues with some of the national monuments that we have, kind of seeing the same thing, and in some cases where the foundations are built out of marble or limestone. Limestone reacts very quickly to acid and tends to bubble and fizz away when it's exposed to acid. And a lot of those buildings that have these foundations tend to be losing their foundations. They're actually sinking into the ground. Acid does damage metal. It can also, though, get into soil, and when we say it leaches, it actually mobilizes or makes metals come out of the soil, especially like aluminum or lead and mercury. All right, so that would be another big thing there. Plants will then tend to take, like trees, for example, will take some of these heavier metals up, which is not good for them. But then also, just regular rainfall and runoff will carry these heavy metals that are generally fairly toxic, and they will carry them in the lakes and waterways, where those heavy metals can be passed up the food chain through biomagnification. So biomagnification becomes an issue again as we're taking these toxic metals and we're moving them up the food chain. With that, and that has a lot to do with our issues with mercury. When they talk about limiting how much fish you have because of the amount of mercury in the fish, right? Mercury is being leached out of soils and in the lakes and rivers where fish are taking it up, and by the time it gets to a human that's eating it, there's a much higher concentration of that mercury that ends up getting passed down, like for a fetus, for example. As far as besides how it affects humans and ecosystems, just ecosystems by itself, most organisms are very highly adapted to certain pHs. Right? They like the pH staying a certain way. If you are into gardening, all right, they tell you to do all sorts of tests with the soil to test your soil pH, because certain plants, and when you buy some of these plants, they'll say, like, they give you a range that they do better in a certain pH. If the pH gets too high or too low, then they start to have trouble with that. All right, going back to the animals, and it kind of shows it in this graph over here. This gives you an idea of a range of pH. Like clams need a very specific pH. Same with snails. Frogs are pretty much good with that, with whatever. They have a pretty wide range where they do pretty well in. And if there are big swings in pH, though, that leads to a lot of issues. Acidic soils don't support plant growth very much. So if we have crops or any sort of plants that we're trying to grow and the soils are too acidic, they're not going to grow very well. And a lot of places they'll add like calcium and things that will kind of help to bring the pH back up again to try to fix the soil so the pH isn't too low, so then the plants can survive better and those types of things. When it comes to forests, acid rain harms the trees. It takes leaves off of there. When you see, like in this picture here, like with the red spruce, this is a pine tree. The acid will actually leach some calcium away. It causes the trees to lose their needles. Pine trees have needles which help protect them from pests, for example. All right, if you've ever walked to a pine tree, you're like, okay, that was a little prickly, that wasn't great. But for smaller pests and bugs, they try to avoid those needles as much as possible, because if you're a small pest or bug, it's probably a lot more painful to get stabbed by a pine needle. When the trees lose those needles, it makes it a lot easier for those pests and to get into those trees and harm them or even just destroy them entirely. All right, with that. Now, remember, once again, it's not the areas necessary directly above where all the coal power plants are, and that's where this is talking about here. All right, it's the ones that are downwind from major urban centers. So yeah, maybe around here we're not seeing any major issues, but there are areas that actually are out where we would consider them being wilderness that are seeing issues from all this acid rain. For example, through the Great Smoky Mountains, where the trees are being harmed by all of that excess acid rain and lowering of the pH throughout there. All right, this image is just giving you an idea of what we've been talking about how acid rain can cause issues to trees and what can eventually end up happening to them. All right, where it's showing like the direct damage to the leaves and the bark. All right, and then that reduces photosynthesis and growth, and eventually like the tree can become more susceptible to drought, more susceptible to disease or extreme cold. It just doesn't react very well to major swings and changes in its conditions throughout there, which would eventually cause the tree to die. Something that can help with that, though, is buffering. All right, you can have two areas, and a question like this might come up on your test, where you have two areas, and they both seem very similar, and they both get the same rainfall, and they both get rainfall with the same pH. However, one may see some serious impacts of that rainfall, while the other might not see impacts, or might not see as many impacts from that. And that has to do with what might be underlying that, and that is a buffer. So a buffer says a substance, when present in a solution, has the capacity to absorb the hydrogen ions, which holds the pH relatively constant. Remember, with pH, we're looking at how many hydrogen ions are there, and generally, if they're the differences in those hydrogen ions determines if it's a high pH or a low pH. One of the better natural buffers that is out there, and I've mentioned already before, is limestone. Limestone is a good buffer because when the acid hits it, there is a chemical reaction. One of the ways when I was in college and we had to do rock studies, you could tell if you had limestone is you take a little hydrochloric acid and put a couple drops on the rock, and the rock would start fizzing like you just open a can of pop. That was the chemical reaction of the acid with the calcium carbonate in the limestone. And what was happening is that calcium carbonate was helping to neutralize the acid in the hydrochloric acid. So that makes it a good buffer. Granite, on the other hand, is a very bad buffer. Granite does not react with any sort of acid, which is why granite works really well on countertops. Granite can withstand a lot, and so it makes a good countertop like that. However, if you have a region that has a lot of granite, and you get a serious amount of acidic rain, or maybe there is an area where there's a lot of snow, and that snow melts, there's going to be no neutralizing of the acid, right? Any sort of runoff that occurs from there could go right into a body of water and immediately drop the pH of that water. And that's where this is talking about acid shock. It shocks that large body of water because it immediately drops the pH and can lead to a very high mortality rate for the fish that happen to live there. And sometimes that becomes an issue because with snow, it's springtime. The snow is melting, and now we're dumping a bunch of acidic meltwater into a lake. Well, the other thing that happens a lot in spring is when babies are being born, in terms of animals, especially fish. And that's the spawning times. All right, so things in the lake are spawning. They're laying a bunch of eggs, and those eggs are very susceptible to changes in pH. So if there's suddenly a huge increase in meltwater that comes in, that pH is going to drop suddenly, and that's going to affect the eggs, which could seriously reduce the number of fish babies that are actually being born. So how can we fix this? All right, probably the best way would be right here on top. Most scientists agree that preventing acid deposition by reducing the output of nitrogen oxides and sulfur dioxide. Right, that's the biggest thing. If we reduce the use of fossil fuels, then we will reduce the amount of sulfur dioxides and the amount of nitrogen oxides that are in the air through that. The problem with that is it does become a very political issue. There are countries like the US and China that have huge coal reserves and have a very vested interest in continuing the use of that coal, regardless of the issues that may come with using that coal. All right, that's one issue. Another issue that we see a lot is it doesn't necessarily affect the people that live right where those things are being emitted. This is one of these things it's a downstream issue, where it may happen. It may be us causing it, but we don't see the effects of it. And we've seen with climate change, we've seen with the spreads of illness, that if humans are not immediately affected by it, they don't necessarily react to it as well. Like that. So that becomes an issue with trying to move away from those fossil fuels, those things that would emit sources of acid rain. But that is really the number one solution, is if we reduce the use of coal, or more specifically, we can use a different type of coal. The coal that we mainly use is called bituminous. Bituminous coal has a much higher sulfur content than a coal that has been under more pressure for longer. It's a harder coal. It's called anthracite coal. Anthracite coal is very hard, has a much lower sulfur content. So that is a possibility as well in there. If we can find ways to add buffers to waterways, but that's really expensive. But just increasing energy efficiency. We don't even necessarily have to reduce the use of coal. If we increase our energy efficiency means we're using less energy every time, or the energy that we are using is doing a better job. We're not losing as much. So increasing energy efficiency would, by default, reduce the use of coal that we have. All right, that is the end of the notes. Thanks for stopping by. I hope you are all well, and we'll see you next time.